Hello students, welcome to Darasa Online. My name is Edgar Mshana. I'm teaching basic mathematics. Today we have a very interesting topic that is sequence and series. And in this topic, dear student, we are going to discuss how to find the nth term of the geometric progression. Then we'll continue with the sum of the first n terms of the geometric progression. Then we are going to wind up our lesson with the geometric mean. Dear students, join with me till the end of this presentation. Welcome. Now, dear student, we are starting with the meaning of geometric progression. In mathematics, we are defining the geometric progression, that is a series in which each term after the first is obtained by multiplying the preceding term by a fixed number. Dear student, when we are talking about a geometric progression, there should be a fixed number multiplied to the preceding term. That means to get the second term of the geometric progression, there should be a fixed number multiplied in the first term. And this fixed number is called the common ratio. That's denoted as R. For example, that is example. Suppose the first term of the geometric progression is denoted by G1. Then you want to get the second term of the geometric progression. Remember, there should be the fixed number multiplied to the first term. So to get the second term, we just take that is G1 times R. So G1R, that is our second term of the geometric progression. Then the same, if we want to get the third term of the geometric progression, again, we take the fixed number, that is common ratio R, we multiply to the second term. So in this case, we are going to have, that is G1 R squared. The same apply for the fourth term. That will be G1 R cubic. So this one proceed up to the last term. Now, dear student, we can use these terms that are in geometric progression to derive the nth term of the geometric progression. So this time we are going to derive the nth term of the geometric progression. Now let us arrange these terms vertical this way. That is, because we are going to derive that is the nth term, of the GP. Now let us arrange these numbers in a vertical way. So in this case, we are starting with the first term, that is G1. Now, in the arrangement of these terms, the power of R is less than 1 in each term. That means for G1, is the same as G1 R1 R power 1 minus 1. Then again, we proceed with the second term, that is G2. For G2, that is G1 R2 minus 1. Again, for the third term, this one is equal to, that is G1 R power 3 minus 1. For the first case, we are going to have G1 because r power 1 minus 1, that is r power 0, and r power 0, that is 1. Then for the second term, that is g2, in this case, we have g1 r, because 2 minus 1 is 1. So we have g1 r. And for the third term, that will be g1 r squared. Now by using this trend of these terms that are in geometric progression, now it is possible to find the nth term of the geometric progression. That is, if our interest is to find the nth term of the geometric progression, this will be the same as, that is g1, then we have r. Remember, the power of r is less than 1 in each term. Now in this case, we have n minus 1. And now student, this is the general formula for finding the nth term of the geometric progression. So in this case, dear students, after having the general formula for finding the nth term of the geometric progression, now we can define the letters used in this general term. Remember, Gn, this is the same as the general term. That is called the general term. Or sometimes we say that is the nth term of the GP. Remember, GP, that is the geometric progression. And also we have G1. As I said earlier, G1, this is the first term. That is the first term of the given GP. And of course, we have R. R, that is the fixed number that is multiplied in each term of the geometric progression. So therefore, R, we call this is common ratio. That is common ratio. Of course, we have another letter that is N. So in this case, N, this is the number of terms. That is the number of terms. Now, student, after having this general formula of finding the nth term of the geometric progression, now it is time to do examples. Now, starting with the first example, that is find the 8th term of the series 2 plus 4 plus 8. We have the series, then we are supposed to find the 8th term. Now in this case, that is example number 1. In this case, we have G1. Remember, G1, that is the first term in the given series. So in this case, we have 2. Then the common ratio. Remember, the common ratio, we take the second term, divide by the first term. So in this case, we have 4 divided by 2, which is equal to 2. So in this case, the common ratio is equal to 2. So we need to find G8. So G8 is how much? That means N, number of terms, is equal to 8. Now, using our general formula for finding the terms in geometric progression, we said Gn is equal to G1 Rn minus 1. So we are looking for G8. Therefore, G8 is equal to G1. G1 we have 2, then times Then we have R, that is common ratio. Common ratio, we have 2, bracket of, then we have 8 minus 1. So in this case, we have 2 times 2 raised to 7. So this is the same as 2 times, so we have 2 raised to 7, which is the same as 128. So take 2 times 128. This one is equal to, we have 16, then carry over 1. Then we have 2 times 2 is 4, plus 1 we have 5. Then we have 256. So in this case, we say the eighth term is 256. So students, I hope we are together. Let us proceed with the second example. This time we are supposed to find the number of terms in the series, that is 1 plus 2 plus 4 up to 512. So the second question, now given, we have the first term, which is equal to 1, and I'm sure you know how to find it, the common ratio. That is, we take the second term, divide by the first term. In this case, we have 2. Then again, we have been given the last term, that is the last number in that series. So here we have Gn, which is equal to 512. Now you remember our general formula of finding the nth term of the geometric progression. That is, Gn is equal to G1 R power n minus 1. But Gn is 512. So here we have 512 is equal to G1, we have 1 times. Now common ratio, in this case we have 2, then we have n minus 1. That is 2 raised to n minus 1 is equal to 512. In this case, our base here is 2. Now let us find how many 2's are in 512. There is a simple way of finding 2's that are in 512. That is 512 just divide by 2, because 2 is our base we are looking for. So on dividing by 2, we have 256. Then again, we proceed with 2. In this case, we have 128. So again, by 2, we have 64. Again, proceed by 2. That is 32. In this case, by 2, we have 16. By 2, we have 8. Then by 2, we have 4. By 2 is 2. Then by 2 is 1. Now in this case, you can count the number of 2's that are in 512. Now simply we have, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So in our question, that is 2 power n minus 1 is the same as 2 power 9. So since the base are the same, then we can compare the exponent. So on comparing the exponent, that is comparing the exponents. So here we have n minus 1, which is equal to 9. So in this case, n is equal to 9 plus 1. So n is equal to 10. Remember, in sequential series, n represents the number of terms. So the number of terms that are in that series is equal to 10. Therefore, we say the number of terms, we say the number, that is the number of terms are 10. So students, again, I'm sure that we are together and you are enjoying this lesson. So my dear student, let us proceed with the third example. That is, if the fourth term of a geometric progression is 9 and the sixth term is 81, find the common ratio and the first term. So given that is G4 is equal to 9. But again, we have G6. This is equal to 81. Now in this case, we are supposed to find the common ratio and the first term of a geometric progression. The general term, that is Gn, is given by G1 Rn r power n minus 1. So starting with G4, that is G4 is equal to G1 R. Now in this case, n is equal to 4. So 4 minus 1, we have 3. So this one is 3. But again, this one is equal to 9. So in this case, we have G1 R power 3. This one is equal to 9. So student, call this equation 1. For G6, that is, again, using the same formula, Gn is equal to G1 Rn minus 1. So for G6, this one is equal to G1 R, we have n minus 1. This time we have 6. So 6 minus 1, we have 5. But this one is equal to 81. So here we have 81. So G1 R power 5 is equal to 81. So student, call this one equation 2. So student, call that one equation 2. Now in this case, we say divide. In this case, we say take equation 2 divide by equation 1 above. So we take G1 R power 5 divided by equation 1, we have G1 R power 3, which is equal to 81 over 9. So in this case, we have R power 5 minus 3 is equal to 9. So we remain with R squared. This is equal to 9. Now finding the square root, we have R is equal to square root of 9. So in this case, we are going to have two values of R, that is plus or minus 3. So in this case, we say R is equal to 3 or negative 3. So it is time to find the first term. So in this case, say using equation 1 above. So in your first equation, that is G1 R power 3 is equal to 9. Now starting with R is equal to 3. That is 4 R is equal to 3. We have G1. 3 cubic is equal to 9. So we have 27 G1. This is equal to 9. So to find G1, divide by 27 from both sides. So G1 is equal to 9 over 27. In this case, we have G1 is equal to, you can simplify by 9, 1. By 9 is 3. So we have 1 over 3. So we proceed with R is equal to negative 3. That is for R is equal to negative 3. Now using the same equation, that is equation 1, we have G1 R power 3 is equal to 9. This time R is a negative 3. So we have G1 negative 3 power 3 is equal to 9. So negative 3 power 3, that is negative 27. So negative 27 G1, this is equal to 9. To get G1, divide by negative 27 from both sides. So by negative 27, so G1 is equal to, now by 9 is 1, by 9 is 3. So we have negative 1 over 3. So in this case, my dear student, we have two values of common ratio and the two values of the first term. So therefore, common ratio which is R, this is equal to 3 or negative 3. And the first term denoted as G1, this is equal to 1 over 3 or negative 1 over 3. So my dear student, I hope we are together. Now let us proceed with the sum of the first n terms of the geometric progression. So, dear students, this time we are going to derive the general formula of finding the nth term of the geometric progression. Now, consider the terms that are in geometric progression. That is, consider the sum of terms that are in GP. So in this case, of course, we are talking about the nth. Consider the sum of n terms. Consider the sum of n terms that are in geometric progression. That is, SCN will be equals to, now we have the first term that is given by G1, then plus with G1R, then again plus G1R squared, then plus this one proceed to G1Rn minus 1. Now, suppose we multiply by R, that is, multiply by R from both sides. But of course, call this equation 1. On multiplying by r from both sides, we are going to have, that is r SN is equal to G1R plus G1R squared, then plus G1R cubic, then plus this one proceed to G1R power n. And of course, call this equation 2. Now suppose we subtract, in this case say subtract equation 2 from equation 1. Just take equation 1 minus equation 2. In this case, we have the following. That is SN minus R, SN will be the same as, that is G1 minus G1 R power n. That is what is going to remain on subtracting equation 2 from equation 1. So in this case, SN is common, so we have SN out of the bracket. Then we have 1 minus R, which is equal to, now G1 is common. We have G1 out of the bracket. We have 1 minus R power n. Now our interest is to make SN the subject. So SN will be equals to, that is SN is equal to G1 bracket of 1 minus R power n over 1 minus R. So we have the first formula of finding the sum of the geometric progression. Again, suppose we take equation 2 minus equation 1. Now this time we take equation 2 minus equation 1. That is subtract equation 1 from equation 2. So in this case, we have R SN minus SN, which is equal to, now this time we have G1 R power n minus G1. So again, SN is common. So we have SN bracket of R minus 1. So in right hand side, G1 is common. So we have G1, then R power n minus 1. So making SN the subject, we have SN is equal to G1 bracket of R power n minus 1, this one over R minus 1. So dear student, we have the second formula of finding the sum of the geometric progression, or the terms that are in geometric progression. Now, where are we applying these formulas? What condition needed to apply among the two formulas? For the first formula, that is SN is given by G1 bracket of 1 minus R power n over 1 minus R. The condition is R should be between -1 and +1. That is the condition. When R is between -1 and +1, then we use the first formula. But for the case of the second formula, that is when R is greater than 1. So in this case, here R is greater than 1. Now you can see the differences are between the two formulas. Where to use the first formula, and again, where to apply the second formula. For the first case, the R should be between that is -1 to +1. But for the second formula, that is R should be greater than 1. Now, after having these two formulas, it is time to do examples that will use these two formulas. Now, students, we continue with examples. And this time we have the question that needs the use of the two formulas. We have the first question, that is, find the sum of the first 7 terms of the GP. Now the given GP is 16 plus 8 plus 4 to infinity. So students, in our question, that is 1, we are supposed to find the sum of the first 7 terms, where the first term of the geometric progression, that is G1, is equal to 16, and the common ratio, you remember how to find the common ratio. Take the second term, divided by the first term. In this case, we have 8 over 16, which is equal to a half. Then n, our n is equal to 7. That is the sum of the first 7 terms of the geometric progression. Now, we are looking at the value of common ratio. Now, which formula is applicable? Remember, we are having 2 formulas, the first one and the second one. Now, in this case, we use, that is, SN is equal to G1 bracket of 1 minus R power n over 1 minus R. Why this formula? Because R is less than 1. We have R is equal to a half. So we have to use this formula of finding the sum of 7 terms of the geometric progression. So that is S of 7 will be equals to, starting with the G1, 16. That is 16. Now bracket of, then we have 1 minus R power n, that is 1 minus, then 1 over 2. This one is raised to 7. Then bracket. Of course, here we divide by 1 minus 1 over 2. So in this case, we have 16 bracket of, we have 1 minus. Now just take a half power 7. In this case, we have 1 over 128. So that is 1 over 128. Now this one over a half, that is 1 minus a half. So here we have, so a half, it will be 16 times 2, we have 32, then bracket of, then 1 minus 1 over 128. Now in this case, we have 127 over 128. So this one is the same as 32 times 127 over 128. So in this case, dear student, we have 127 over 4. Now you can convert this one to mixed numbers. So in mixed number we have dear student, in mixed number we have 31 and 3 over 4. That is the sum of the first 7 terms of the geometric progression. So student, again, I'm sure we are together. Now let us continue with the second example. That is the sum of the first 4 terms of a geometric progression is 80. If the common ratio is 3, find the first term. Now this time we are supposed to find the first term of the geometric progression. So given that is number 2, again here we have the sum of 4 terms of the geometric progression. This one is equal to 80. And again we have the common ratio. So here R is equal to 3. We are supposed to find the first term, that is G1. So in this case, the number of terms is equal to 4. So here N is equal to 4. So R is greater than 1. So here we have SCN is equal to G1 bracket of, that is Rn minus R power n minus 1 over R minus 1. So here SCN, that is S of 4, we have S of 4 is equal to G1, then bracket of, we have 3 raised to 4 minus 1, this one over 3 minus 1. So students, remember S4 is equal to 80. So in this case we have 80 is equal to G1 bracket of, we have 3 raised to 4, that is equal to 81, then minus 1, this one over 3 minus 1, we have 2. So in this case we can cross multiplication. So we have 80 times 2, we have 160, which is equal to 81 minus 1, we have 80, then G1. To find the G1, you can divide by 80 from both sides. So in this case, G1 is equal to 160 divided by 80. So the first term will be equals to 2. So here we say the first term needed is, that is equal to 2. So again, student, I'm sure you are enjoying this lesson of sequence and series. Then let us see the last example that needs to use the formula for finding the sum of n terms of the geometric progression. So we have the third example, 33. So given that is, if the first term and common ratio of GP are 5 and negative 1 over 3 respectively. So we have the first term, that is G1. This one is equal to 5, and the common ratio is equal to negative 1 over 3. Then we are supposed to find the second term, that is G2, that to find G2, and the sum of the first 3 terms. We have to find S of 3. In this case, we're looking for S of 3. That is the sum of the first 3 terms. Now, dear student, we are starting with the Gn is equal to G1 R power n minus 1. That is G2 will be equals to, now G1 is 5, then R we have negative 1 over 3 raised to 2, now n is 2, so we have 2 minus 1. So this one is equal to 5 bracket of negative 1 over 3. Remember 2 minus 1, that is 1. So in this case we have negative 5 over 3. Therefore G2 is equal to negative 5 over 3. That is the second term of the given geometric progression is equal to negative 5 over 3. Now we proceed with the sum of the three terms of the same geometric progression. So for the case of sum, this time R is equal to negative 1 over 3. So we have SN is equal to G1 bracket of 1 minus R power N, then again over 1 minus R. So we're looking for the sum of three terms of the geometric progression. So that is S of 3 is equal to, now G1, remember that is 5. So here we have 5, then bracket of, we have 1 minus, now common ratio is negative 1 over 3. So we have negative 1 over 3, but this one is raised to 3. Then over 1 minus, common ratio is negative 1 over 3. So this one is equal to 5, bracket of 1 minus. We have negative 1 over 3 cubic, which is the same as negative 1 over 27. So this one is over, then we have, that is 1. That is 1 minus 1 over 3. Of course, this one is plus the same 2. The same 2, of course, here that is 1 plus 1 over 27. So in this case, we take 1 plus 1 over 3. So here we are going to have 4 over 3. This is 4 over 3. So we have 5 times. So we have 1 plus 1 over 27. This will be 28 over 27. So again, this one over 4 over 3. Now, on arranging these numbers in fraction, we have 5 times 3 times 28 over 4 times 27. Now you can simplify. That is, by 4 is 1, by 4, that is 7. But again, by 3 is 1, by 3, this one is 9. So in this case, S of 3 will be equals to, that is 5 times 7, we have 35. This is 35 over, then here we have 9. So that is over 9. Or in mixed number, S of 3 the same as 3 and 8 over 9. Now, let us proceed with the geometric mean. Now, for the case of a geometric mean, again consider three numbers that are in a geometric progression. So that is, consider three terms that are in geometric progression. The first one, let's say it is A. The second one is M, and the third one is B. Now, if this sequence in geometric progression, it is possible to find the common ratio. That is, m over a is the same as b over m. That is how to find the common ratio in the geometric progression. Now, let us do cross multiplication. That is m times m. We have m squared, which is equal to ab. So finding m, we are saying m is equal to square root of ab. Therefore, geometric mean that's denoted by m is equal to square root of a times b. In this case, a will be the first number and b will be the second number. So, student, after having the formula for finding geometric mean for two numbers, then, of course, this is our general formula. Geometric mean is equal to the square root of a times b, where a is the first number and b is the second number. Now let us proceed with examples to apply our general formula. So we have the question here, that is, find the geometric mean of 4 and 25. We have two numbers, that is 4 and 25. So in this case, that is 1. Of course, you can say A, that is equal to 4, and B is equal to 25. Our formula, that is geometric mean, this one is equal to the square root of A times B. So in this case, we have 4 times 25 under the root, which is the same as 100. So this one is equal to 10. Therefore, the geometric mean between 4 and 25 is equal to 10. Now, let us see the second example. This time, that is, given the geometric progression 4 plus x plus 36, then plus proceed to infinity, find the value of x. Now given, we have the series 4 plus x plus 36 to infinity. We are supposed to find the value of x if the series are in geometric progression. So in this case, it's the same as find the common ratio. Remember, common ratio is the same as the second term over the first term, which is the same as the third term over the second term. So in this case, we have x over 4, which is the same as 36 over x. So cross multiplication, we have x squared is equal to 4 times 36. Now to get x, we're saying x is equal to square root of 4 times 36. We can find the square root of each number and then finding their product. So here x is equal to the square root of 4. This is 2. Then times the square root of 36, we have 6. So in this case, the value of x is equal to 12. But of course, you can use formula, that is to find the geometric mean by saying m is equal to square root of a times b. That is the alternative method. So using the alternative method, that is alternatively, that is geometric mean is equal to the square root of A times B. The middle number is missing, so A will be equals to 4 and B will be equals to 36. So in this case, geometric mean the same as the square root of 4 times 36, which is the same as the square root of 4, that is 2, then times the square root of 36, that is 6. Therefore, geometric mean be equals to 12. Now, the third example, that is the geometric mean of two terms 4 and y is 24. Find the value of y. That is our last example. So that is number 3. That is let A is equal to 4 and B is equal to y. And of course, geometric mean between 4 and y is equal to 24. Now, using our general formula of finding geometric mean, this is equal to square root of A times B. That geometric mean is 24. So this is equal to the square root of 4y. On a squaring from both sides, we have 24 squared. This is equal to square root of 4y squared. We have 576, which is equal to 4y. So to find y, just take y is equal to 576 over 4. Therefore, the value of y is equal to, just take 576 divided by 4. The value of y is equal to 144. Therefore, the unknown value of y is equal to 144. Here there is the assignment for you. The first equation, that is, in a certain geometric progression, SN is equal to 1,248. That is the sum of n terms. And the common ratio is equal to 5. And the number of terms, that is n, is equal to 4. In this equation, you are supposed to find the first term. I'm sure you are able to do this question. Then, dear student, we have the second assignment question. That is, find the geometric mean of 49 and 81. You know the general formula of finding geometric mean. Then use it so that you can do the second question. Then the last question for you, that is, given the geometric progression as 2 plus 6 plus 18 plus to infinity. In this question, you are supposed to find the sum of the first 8 terms. You know the general formula of finding the sum of n terms, and there you have 2 general formulas. Now try to read your question and choose a suitable formula that will help you to find the sum of the first 8 terms. So my dear student, I hope you enjoyed this lesson that is in basic mathematics. The topic was sequence and series. Subtopic was geometric progression. Don't miss another lesson of basic mathematics. Till the next time, have a good time. Bye.